Hello. So today we will continue our discussion on chapter 35, which is about light and optics. And in particular, what we will be doing is solving exercises on all the rules we obtained in lecture 17. So a quick reminder, reflection occurs whenever the light hits a smooth surface, and the law for reflection is that theta incidence is equal to theta reflected, okay? And for refraction, it obeys Snell's law, which is N incident or N1, that is the index of refraction from the first medium, times sine theta incident is equal to N2, which is the index of refraction of the second medium, times theta refracted. And you have to go back to the summary for refraction of light, because we found that at some particular thetas, total internal reflection might occur, okay, especially if we are moving from a medium of index of refraction N1 higher than index of refraction N2. So we need to find, there is this theta critical that causes total internal reflection, okay? So now let's do some exercises. We will start with one exercise on reflection. The reflecting surfaces of two intersecting flat mirrors. So here, if you can see, we have two mirrors. This one. And this is mirror 1, and this is mirror 2, okay? Where the angle between them is less than 90. It's between 0 and 90, this angle theta between them, as shown in the figure. For a light ray that strikes the horizontal mirror, show that the emerging ray will intersect the incident ray at an angle beta equal 180 minus 2 theta. So this is the incident beam, okay? This is the incident beam over here. And we need to show that this angle here, beta, this angle here, beta, is equal to 180 minus 2, this angle here, theta. Okay. In order to do so, we're going first to look at this triangle, A, B, C, okay? So in this triangle A, B, C, what do I have? I have beta plus 2 alpha plus 2 gamma is equal to 180, right? This is 180 degrees. Now, if I look at this triangle, B, C, D, okay, what do I have? I have theta plus 90 minus gamma plus 90 minus alpha is equal to 180. In other words, I have 90 plus 90, so this is 180 plus theta, or 180 plus theta minus gamma plus alpha is equal to 180. 180 will cancel out the 180, and I will have left theta equal gamma plus alpha, because I will have theta minus gamma plus alpha is equal to 0. So theta is gamma plus alpha. 2 theta is how much? 2 theta is 2 alpha, or is 2 alpha plus 2 gamma. Now, if I plug this thing here in this equation, so I will have beta plus 2 alpha plus 2 gamma, which is 2 theta, is equal 180 degrees, or in other words, 1 beta is equal, if I take 2 theta to the other side, it is 180 minus 2 theta. Okay, and I prove what they want me to prove. Let's do another exercise, also applying. So here you find the full solution. So first we start with triangle ABC, and we write that the sum of the 3 angles is equal to 180, which gives me angle beta is 180 minus the sum of the 2 other angles. Then in this small triangle, I have also the sum of all the angles is 180. I will get here, because 90 plus 90 is 180, it cancels out with 180, and I will have theta equal alpha plus gamma, which means 2 theta is equal to alpha plus 2 gamma. I plug it up here, and I will get beta is 180 minus 2 theta. Okay, the 2 mirrors illustrated in the figure below meet at a right angle. So here I have mirror 2 and mirror 1, and they meet at a right angle. Okay, so here, this thing over here is 90. The beam of light in the vertical plane, this is the beam of light. Indicated by the dashed line, strikes mirror 1 at an angle 40. So this angle over here is 40. As shown in the figure. Determine the distance reflected light beam travels before striking mirror 2. So what happens when this beam strikes mirror 1? It will get reflected. It will get reflected at an angle of 40, right? So this angle is here is 40. This angle here is 40, okay? And I need to calculate this distance. This distance over here. Okay, look at this triangle, A, O, B. Okay, it's not clear. I'm gonna put dots. So this triangle, AOB. Okay, this angle up is 40. So this angle here is 50, because the summation of the 2 is 90. And if I take cosine of angle 50, cosine of angle 50 inside this triangle, the cosine of this angle is equal to the adjacent side, which is 1.25, divided by the hypotenuse AB, which is the distance D that the question is asking me to calculate. So implies D is 1.25 divided by cosine angle 50. And this gives me 1.94 meter. Now, in what direction? So this is part A. Part B. In what direction does the light beam travel after being reflected from mirror 2? So this light beam here, this angle here is, this angle here, let me put it properly. This angle here is 50. This angle here is 40. So this angle here is 50. Okay. And this light beam hits the mirror. It will get reflected in such a way that it will make, so let's draw the normal. Okay, so this is the normal. It will get reflected from this normal with what angle? This angle over here is equal to this angle over here. This is 50, this is 40, so this is 50, and this is 50. So it will get reflected with angle 50 with the horizontal. 50 is with the okay. Let's look at this drawing. Maybe this is the solution, and here I'm drawing an easier drawing. So here I'm only showing the mirror as one line, and this is the other mirror as one line. So the incident ray is making angle 40 degrees. It will get reflected with angle 40 degrees, okay? So this angle over here is 50 because the whole angle is 90. If this is 50, this is 40. Now look at this triangle over here. I have this side 1.25. If I take the cosine of angle 50, it's the adjacent, which is 1.25 divided by D, and I get D is 1.25 divided by cosine 50. And then it will be, this angle here is 40, so the incident angle is 50, so the reflected angle is 50. Okay. Now, an opaque cylindrical tank with an open top has a diameter of 3 meters. Okay, so this distance from here to here is a 3. And it's completely filled with water. So there is water everywhere. So outside there is air, n equal 1. And inside there is water, n equal 1.33. When the afternoon sun reaches an angle of 28 degrees above the horizontal, so if this angle here is 28 degrees, okay, sunlight ceases to illuminate any part of the bottom of the tank. How deep is the tank? So here we have to apply Snell's, sorry. Here we have to apply Snell's law. So we need to find the depth of the tank, which is h. This is theta incidence. If this is a 28, theta incidence over here is 62 degrees, okay? Because this is the normal to the surface, and this is the angle of incidence. It is 62. So we apply Snell's law, n air times sine theta incident is equal to n water times sine theta 2. They're calling them theta 1 and theta 2. So let's stick to the same notation. Okay, n of air is 1 times sine of 62 is equal, n of water is 1.33 times sine of theta 2, and I will get sine, I will get theta 2 is equal shift sine of sine 62 divided by 1.33, and this gives me the answer 41.5 degrees. Okay, so I got this angle. Now if I look at this triangle, okay, and I take, I have this side, which is the opposite, and I need the adjacent. So I have to take the tangent. So tangent of theta 2 is equal opposite, which is a 3, divided by h. So h is equal 3 divided by tangent of theta 2, which is 41.5. And the answer is 3.39 meters. Okay. The last exercise we will do today. Light of wavelength 700 nanometers is incident on the space of a fused quartz prism n equal 1.458. Okay, so, and here is 1.458. At an angle of incidence theta initial equals 75 degrees. So this angle here is 75 degrees. 75. So this is the angle with the normal. The apex angle of the prism, that is this angle over here, is 60 degrees. Okay, now let's start. So the first part, calculate the angle of refraction at the first surface. Okay, so this is the first surface. And this is the normal. Okay, so this is theta incident. It will enter and it will get refracted by this angle here, theta 2. So to calculate theta 2, we apply n air or n1 times sine theta 1 is equal n2 times sine theta 2. I just put the numbers. Theta 2 is equal shift sine of n1 sine theta 1 divided by n2. And if we apply the numbers, so theta 2 is equal sine of n1 is 1 times sine 75 divided by n2 is 14.458, and this gives me 41.5 degrees. Okay. Part B. The angle, so we have just calculated this angle over here. Now, calculate the angle of incidence at the second surface. So this is now the second surface. Let's now focus on the second surface. Okay, and this is the normal to the second surface. And we want to calculate this angle over here. It is the angle it makes with the normal. The light ray makes with the normal. So we want to calculate this theta 3. Okay, we need to first look at this triangle over here. The sum of the three angles, that is 60 plus alpha plus beta. So I have 60 plus alpha plus beta is equal to 180. How much is alpha? We calculated theta 2 to be 41.5. So how much is alpha? So this is 60 plus alpha is 180 minus sorry, not 180. It is 90 minus theta 2, which is 41.5. Okay, plus beta is equal to 180. So this whole angle here is 90. Alpha plus theta 2 is 90. Remember, this is the normal. I have theta 2 is 41.5. So I calculate alpha by 90 minus 41.5 plus beta equal 180. from here, I will get beta is equal 71.5 degrees. So I calculated this beta. This angle theta 3 is 90 minus beta, which is 90 minus 71.5, which gives me 18.5 degrees. So theta 3 is 18.5 degrees. Part C, the angle of refraction at the second surface, okay? If they didn't tell me find the angle of refraction at the second surface, I would have done it the long way, and that's how I did in the solution. First, I calculated how much is theta critical. You calculate how much is theta critical by applying N1 sine theta critical is equal N2 sine 90, because we know that the refracted angle will be 90 degrees. So from here, if I put N1 and N2, we calculate that theta critical is equal to, by numbers, we find theta critical is equal 43.34, sorry. Now, if this theta here was above theta critical, then total internal reflection would have happened. But our theta 3 is less than theta critical, implies refraction occurs, and when refraction occurs, which means N1 sine theta 3 is equal N2 sine theta 4, and from here you calculate theta 4 by just plugging instead of N1. Here you have to remember that we're going from N1, which is 1.458, to N2, which is 1 in this case, because we're moving from a glass to air. So N1 in this case is 1.458 times sine theta 3 is 18.5 equal to the other medium, which is 1 times sine theta 4, and we find that theta 4 is equal to shift sine of 1.458 times sine 18.5. Just a second. And this gives us theta 4 is equal 27.6. Was it necessary to do this step by calculating theta critical? In fact, in this, usually it is necessary if they did not specify over here that the angle of refraction happened, okay? So here they told me that refraction happened. So I could have directly started with N1 sine theta 3 equal N2 sine theta 4. But I'm doing it the long way because sometimes they may not tell you that refraction happens. They will tell you, calculate what will happen to the light after this beam hits the second surface. So then you have to see if the angle is higher than theta critical, then total internal reflection will happen with an angle equal to the incident angle. And if it is less than, so refraction will happen just like what happened in this problem. Okay, now the last part, part D, the angle between the incident and the emerging rays. Okay, where is the emerging ray? The incident ray. This is the incident ray. This is the initial incident. Let me erase first all this. So this is the incident ray. And this is the emergent ray. Okay, this is the first ray that hit the prism. It got refracted, then it got refracted. So this is the emergent ray. And we need to calculate this angle gamma. This is easy. This angle gamma is nothing but the absolute value of theta 2 minus theta 1. That is the resultant from this minus this, or this minus this, depending which one is bigger. Okay, plus the absolute value of theta 4 minus theta 3. Okay, so what is theta 2? Theta 2 is 41.5 minus 75, but this should be in absolute value. Plus absolute value of theta 4, which is a 27.6, minus theta 3, which is 18.5. And this will give 42.6. By this, we reach the end of today's lecture. Also, in the coming lecture, I will be doing more exercises on reflection and refraction. Until then, bye-bye.